Hi there. Today we're going to talk about increasing and decreasing functions, and we're going to go into some particulars, in particular about the domain and range, and what happens when we write functions as a property of their derivative. So I want to start this shoot by talking about the definitions of what constitutes an increasing and decreasing function. So with an increasing function, so if the value of y increases on the increasing x, we call this an increasing function. Now, obviously, in a lot of circumstances, we talk about x and y being our two variables, y being our dependent variable, and x being our independent variable. In relation to increasing functions, what we're actually saying is that the dependent variable is increasing with respect to an increasing independent variable, x. And this is shown by our function notation of f of b being greater than f of a, where b is greater than a. So this is what we term as an increasing function. When we discuss a decreasing function, it's the opposite. So if the value of y decreases, remembering that y is our dependent variable on the increasing independent variable x, then we call it a decreasing function. And what we say here is that f of b is less than f of a, where b is greater than a. So we have to understand those definitions, and we have to talk about those definitions, what they mean in terms of the function and the graphical representation of that function. So I'm going to talk a little bit about the graphical representation of a function. So obviously we could have a function that looks like anything. I'm just going to take a standard cubic function because they're nice to represent what increasing and decreasing are saying. And let me sketch that again. Okay, so here we have a function. Okay, obviously our dependent variable we're calling y, our independent variable x set on the two axes, and I'm going to say that this point here is going to be a f of a, and this point here is going to be b f of b, and the cubic function we're going to call fx. Okay, so obviously our turning points are going to play a significant role in determining where the function is increasing and where the function is decreasing. If I talk about my increasing function, so increasing function, that's obviously where the gradient of the function is going to be positive, okay? And that's going to run all the way up to a, and here I have from b to infinity, that being also increasing. So those two sections of the graph, they're increasing functions. So I'm just going to highlight that as so. And when we write the domain for this, we're going to say that x belongs to negative infinity. We use an round bracket or a curved bracket for this because, you know, we never actually reach negative infinity. Okay. But when we come to the point A, so this point here, we're going to use an inclusive bracket. That's very important. So when the function actually reaches A, it's still increasing at A, even though the derivative at A or the gradient of the tangent at A would equal 0. We're saying that it's increasing all the way through the graph, all the way to this point, and that's including that point A. We're also going to say that it's in union with B and then to infinity, and that's our increasing part of this function. I just want to highlight here that it is very important that we use these inclusive brackets for where the turning points are for increasing functions. Okay. When we talk about a decreasing function, though, where the function decreases, so decreasing function, and we want to specify what the domain of that is going to be, that's going to exist in this region where the function is, all the y values are declining between a and b. And we're going to say that the domain of this is going to be equal to a to b. And again, we use inclusive brackets, the square brackets, to mean that a and b are where they're decreasing. So we just need to make sure that we get our notation correct, especially our notation for our domains correct. And that's going to be very important. Now, there is a slight difference that you can find in questions, and we might have a question that says something like this: state the values of x where f dash x is less than 0. So f dash x less than 0 means that the gradient is going to be negative. We're going to have negative gradients all the way through here. Okay. Now, if I wrote here that x belongs to, or if I wrote x belongs to a to b, that's actually incorrect. So we don't want to do that. Okay. Why is it incorrect? Because the gradient at a and the gradient at b, okay, is going to be equal to 0. So it's actually not less than 0. We have to stipulate where it's going to be less than 0. The correct answer would be x belongs to AB. And here we're using exclusive brackets. Okay, so the curved brackets meaning that A and B actually aren't part of this condition of f dash x is less than 0. Why? Because the gradient at A will be equal to 0 and the gradient in B will be equal to 0, and that's not less than 0. Okay, so we say f dash x less than 0 exists at between A and B exclusive. Okay, we could also say state the values of x where f dash x is greater than 0, and this would be x belonging to, we would therefore run from negative infinity, and remember we're going to have positive gradients running in this region and positive gradients running all in this region, but we are going to put a, but we're not going to include a, so it's going to be exclusive in union with b, okay, to infinity. And I just want to highlight again that we're using the exclusive brackets here. Okay, now there is and before we move forward, we just want to make that distinction between the two type of questions that they could ask. So you could have a question that states, state where the function is increasing. If that's the case, we're going to use this notation and this kind of concept. However, they could say, state where the values of x or for values of x where f dash x is greater than 0. And in that case, we're going to use this type of concept. So just be aware of that. Now, the other concept that you might want to um, consider is you could get a question, state where y equals x to a third is an increasing function. Now, this might seem a little strange, but if I sketch x equals a third, or x to the power of a third, this function is going to look like this. It'll have a point of inflection. Let me take that out. Have a point of inflection and it'll curve out like so, and curve out like so, like that. And we'd have our y-axis and our x-axis here, and this is our function y equals, the cube root of x. This function in all places is increasing, and the point of interest which we want to consider is this point at 0, 0. That's because the gradient at this point, or the gradient of the tangent at this point, will be equal to infinity, or it'll be undefined. However, x is still or y is still increasing with respect to x increasing. So therefore we consider it a increasing function. So we say increasing function, and we're going to say x belongs to all real numbers. That's it for today. I hope you enjoyed the video.